that these are correct before we go on?
9.6 is 84.
9.6.
Yeah, we're gonna 6 1.
Okay, gotcha. So this guy right here should be 84. Okay. All right. Any of the other ones that might be incorrect? Because of course, when we do it the other way, I want to make sure we get the same answer. So you guys at least believe me that there's another way to do it. All right. And then of course, guys, we're going to add all these up. So let's just go ahead and stick it in the calculator. And then when somebody gets a sum for this, actually a couple people get a sum, so that way we can all make sure we got the right answer. We didn't make any typos in it. Find a calculator, I'd do it. Sorry.
19440.
19440. All right. Thank you, Mr. Weber. Now, just to verify, not saying he's lying to us, but
Unless I typed it wrong.
How can 94 and 95 both be
symmetric.
9.6 and 9.3 are also
Yeah.
both 84.
Yeah, the binomial distribution is symmetric, so if it's equidistant from an average value,
Got it.
so it's just like a normal distribution. So, except it's a binomial distribution, which actually approaches the normal distribution as the sample size becomes infinitely large, central limit theorem, regardless. But this is the statistics. Okay, so that's a hard way to do it. All right. Maybe there's an easy way to do it. I don't know, and maybe we got that right. So, all right. Let's think of it another way. All right. Couldn't we figure out the total number of 7-person juries and subtract what?
All men.
Yeah, just basically the all-man jury, right? Because basically, we could say that this jury, that's at least one man, basically is every possible 7-person jury except for the one that's all men. Okay, so if we knew the total juries, so we'll say or, we could say the total number of juries minus the juries of all men, okay? That's a faster way to do it. Not saying it's easier, okay? In fact, it'd probably be easier to do it the top way logically, okay? This way is probably going to give some of you guys fits, because you're like, well, how do I even figure out the total number of juries that can be picked? Or how do you set that up, okay? So I'm just trying to give you guys 2 different ways to do it, so if you see this on an exam, at least you know one of 2 ways to do it. All right. What's the total number of ways that I can pick a 7-person jury? See, that's why it's not as easy.
Would it be 7,
17-7. How'd you get 17? I don't see a 7 up there. 17 anywhere.
I added the 8 men.
Yeah, 8 plus 9 is 17, right? There's a total of 17 people, of which we want 7. Isn't that the total number of ways that we can pick the jury? Okay, that makes sense to me. Nice, Greg. All right, what about all men? Well,
8,
yeah, it'd be 8-7, and by default, 9-0, right? All right. So that's the faster way of doing it, but again, you have to be smart enough to set it up like that, okay? So it seems like the first way is just more intuitive for you guys, just because you just beat it up and do it, the brute force of the bully method of doing it, okay? All right, so if somebody could be so kind into their calculator and do 17-7, I bet you it's going to be 19,448, because 8-7 is 8, and 9-1 or 9-0 is 1. But if somebody can verify that just to make sure we're good with that. That looks good? Okay. And 19,448 minus 8 is 19,440, which is what we got from before. All right. So, unfortunately, guys, if you have one of these at least problems, if you have a lot of them to do, it might be beneficial to try to think of it like the total minus maybe 1 or 2 of them, okay? That's called the complement of that, okay? But if you can't think of it like that, like if you're sitting there and you're like, I just can't do it, just bully it, okay? I mean, quite honestly, how long is that going to take you guys to do? Like 5 minutes at the most to check it twice, okay? So, I mean, it doesn't matter which way I do it, except if we start having, what, like 30-person juries, and then I say at least 1, then it better matter, right, guys? Okay. Alright, so questions I can answer about these problems to where we have to select and we do some sort of counting methods with combinations. Okay, so let's go ahead and extend that, and let's extend that to probability as opposed to just going to be counting methods, okay? Now, we talked about probability a little bit last time. Remember, that's the number of desired divided by the total number of outcomes, right? So if we know the number, in other words, these guys right here, that's the number of desired, and then divided by a total number, it should be okay for this, okay? So these aren't any more difficult than what we've been doing, except now we just have to divide by a total. All right, so a box contains 5 red and 7 green marbles. We're randomly selecting 4 from the box, okay? Total number of ways, probability that we pick 3 green and 1 red, probability we pick at most 2 red and then at least 3 green, okay? So let's go ahead and try to knock that one out. The first part's the easy stuff, and then after that, maybe not so easy, so. All right, so how many total ways are there to select the marbles, okay? So anybody have an idea as to perhaps how we can compute that?
There are 12 marbles, right?
Yeah, there's 12 marbles total, right, of which we want 4. There you go. So just 12 choose 4, that's all it is. Okay. Does that make sense to everybody, guys? When I talk about total number of ways, you just add the total, and then you figure out how many you're selecting from there. Okay. And then if you guys would be so kind as to throw that into a calculator. One more time?
495.
495, thank you, I'm sorry. Okay. So, easy enough for that one, right guys? Okay. For item B, okay, so now we're saying probability. So make sure when you guys are doing your homework and also when you guys are taking the exam, note the difference between probability and number of ways, okay? Because if you do the probability and I'm asking you for a number of ways, you haven't necessarily answered the question, okay? You've got the answer somewhere in there, but you haven't indicated it correctly, okay? So the probability that we pick 3 green and 1 red, okay? So basically, guys, we're going to have a fraction. All right, the total number of desired, okay, that's the numerator, okay? Well, guys, how do we pick 3 green and 1 red marble? Well, how many total marbles are there that are green? 7. How many of those do we want? Okay, and it's a combination, right, guys? How do we know it's a combination as opposed to a
It
permutation?
doesn't matter how you or what
Yeah.
I pick them.
The marbles don't have names or anything like that, okay? I can't pick one marble and it doesn't look any different than the other one, right? They're indistinguishable objects, okay? I think we have 5 red marbles, right, guys?
Mhm.
Of which we want 1, okay? So wouldn't the numerator represent the number of possible ways that if there were 7 green and 5 red, that we could pick 3 of those to be green and 1 of them to be red, number of desired in the numerator. What's the denominator? What's the total number of ways?
495.
Yeah, 495, right guys? It's almost like I made you compute that on purpose. Isn't the denominator going to be how many possible ways there are to pick the 4 marbles? Okay, so that would be 12, 4, which we already knew to be 495 from the previous example. Does that make sense to everybody, guys? Not meant to be difficult, it just is what it is, right? Okay, now, what's that?
You can't like add them.
Oh, we're going to multiply these together, John. And then it just
Like,
becomes...
7 plus 5 is 12.
Oh, I see what you mean. Yeah, you can add these to be able to get to the total number. I see what you're saying. Right. So,
12, 4 is the same as that.
right, you're right. It's the same number as this guy right here from the previous.
Oh, no, but it's not the same as 7 over.
Oh, no, it's absolutely not the same. No, it's completely different than that. Okay, I see what you're saying, sir. Okay. Yeah, it's different because of the subtraction in the formula for the combination. Okay, it's not all commutative for this one. It's associated. Okay. All right, guys. So we just go into our calculator. Did anyone figure out 7, 3?
Yeah, it's 35.
35. And that's 5, and the numerator for 5, 1, 495. So then this is just going to be 135 over 495. So if you guys could approximate that to 3 decimal places to get a probability. 0.3535. Okay. So 354. So it's not completely unlikely that that could happen, okay? It's not extremely likely, okay, but it's not like it would never ever happen to somebody, okay? So, does that make sense, guys? When we're computing probability, total number of desired on top, and then in the denominator, it's just going to be how many total possible ways, okay? It's not too difficult. It's the same stuff we've been doing, we're just taking it one step further. Okay. All right, for item C,
So you said percent, 35.
oh, if I was to write that as a percent, John, that would be 35.4%, okay? Usually when we talk about mathematical statistics, we don't even like percentages, because quite honestly, guys, percents aren't even real numbers. They're just ways to represent a part per 100. So this would be like 1% out of maybe 495 or whatever. If we were to do a different number, that would be the expected value for that. Okay? Other questions, guys? Okay. So for item C, this one says, what's the probability that we will select at most 2 red marbles? Okay, so now we have an at most problem. All right. If I want at most, okay, that means I want at maximum 2. So at least means at minimum, at most means at maximum. So what's one possible outcome for at most 2 red marbles?
So
We could have 0 red marbles, right? So one could be 0 red. Okay. What's another possibility?
1 red,
1 red marble, right? What's another possibility?
2 red.
2 red marbles. Could we pick 3 if we want at most 2 reds? No, not possible, right? So when you see the words at most, you start at 0 and then you go up. If you see at least, you start at that number and then you just keep going up to the maximum. Okay, so does that make sense to everybody, guys? Okay, at most means you start at 0. At least means you start at whatever the given value is, and then you just keep going up to whatever the max is. Okay? All right, so now all we have to do is just set up these problems for 0 red. Okay, now remember, if you pick 0 red, by default, you have to pick some greens. Okay, so you're still going to have 2 combinations. All of these problems are going to have them. Okay, sorry. There we go, that's better. All right. So if I want 0 red marbles, okay, what's the combinations set up for both of those? So for the red ones, what would that be? 5 choose 0, okay, and then 7 choose 4. Nice. Does that make sense to everybody, guys? We're picking 4 marbles. We're picking 0 red, so by default, there has to be 4 greens. Okay? There's no other way to pick 4 marbles unless you pick 4 of one and none of the other. Okay? For 1 red, that would be 5, 1. And instead of 7, 4, it would be 7, 3. Right, guys? Okay. And then once you see that, then the rest of it's easy, right? You just keep going up on the reds, down on the greens. So it would be 5, 2, 7. Okay. And then, just like before,
No, 7.
no, 7, 2. I'm sorry. I went the other way. Sorry. Here we go. All right. So that look good, guys? Any questions about that? Okay. And then what's the denominator going to be for this? Is it still 495 or do we change it?
The same 495.
It's the same, right? I haven't changed the number of reds and greens. I haven't changed that I'm choosing 4 marbles. So it's still going to be 12, 4, which we already know to be 495. Okay? Now, as soon as I change and say that we're picking 5 marbles, or if I say, now I'm changing it to 4 red and 8 green, then you got to change the whole thing. Okay? So make sure that if you understand that any of the parameters initially change, the whole thing changes. Okay? Good.
We don't have to use the probability. We only have to use the denominator on a probability.
Correct. If it does not say probability, you just worry about the numerator. Okay, good question, Dave. Okay. Other questions, guys, I can
Now,
answer?
4 red and 8 green, it will be the same as the denominator because there are 12 marbles and you're choosing 4, right? If you said, if I'm choosing 4 reds and 8 green, on the denominator it will be
Yeah,
12.
it would still be the same for
Yeah.
that. But if I change like anything else, like if I
Yeah.
increase the number
Yeah,
that I'm
then.
picking or decrease. Okay, so let's just go through and pick this out or compute this. 5, 0 is 1. 7, 4 should be 35, shouldn't it, guys?
Yes.
Okay. 5, 1 is 5. 7, 3 is 35. 5-2 is 10, 7-2 is 21, I believe.
Yes.
Yes.
Okay. And then we know what the denominator is, 495.
420 over 495.
420 over 495. Okay. And then, that's a pretty high
That
probability.
was 0.849. 848. Well, no, yeah, it's 848.
Is it 848? Okay.
Because it's 8484.
If you were off by 1,000th, I wouldn't slay you guys. Especially since we're doing fictitious problems where we're just picking marbles out of a box. Now, if you were engineering a car and somebody's life was in jeopardy of that, then I might be a little more upset, but no.
Your number doesn't stop there.
Yeah, that's true. You're exactly right. The level of precision would not stop with just 3 decimal places, hopefully. Okay. All right, guys, any questions about this one, guys? Okay, same exact stuff we did before, except now all we're doing is we're just throwing in the total number of ways and dividing by it. Okay. Last one, letter D. What is the probability that we will select at least 3 green marbles? Okay, so this is an at least problem. So again, guys, one of the things you want to make sure of is that you read the condition. Okay, at most, at least. At least, remember, means you start with that number, and then you just keep going up till you hit the max.
Either way, you have 2 things to set up for this.
Yeah, so for this one, at least 3 green. So we start with 3, right, guys? So there will be 3 green, okay? And there will be 4 green. Would there be 5 green? No, you can't pick 4 greens, right? Because there's only 4 marbles that we're picking from. It's not possible to pick 5 marbles or 5 green marbles if you're only given 4 to start with. Okay? For 3 green, 7, 3, 5, 1. For 4 green, 7, 4, 5, 0. We still divide that by 12, 4. We're not changing any of the initial conditions, so we're stuck with what we have there. Okay? The good news is, guys, don't we already know all those combinations from the previous problems? Okay?